In the second part of this two-part presentation of adding unlike fractions, I want to show a few numerical techniques that we started to allude to in the first part. So let's suppose I want to add 3/7 and 5/8. As we saw in the last video, I could simply multiply the first denominator, and I will go ahead and do so as soon as I can get the pen working. I can multiply the first denominator and numerator by 8, which of course is the value of the denominator of the second fraction. I can do the same thing with the second fraction, except here I'm going to multiply the numerator and the denominator by 7. What this does is it creates two equivalent fractions. The first equivalent fraction is going to be 3 times 8 is 24 over 56. The second equivalent fraction is going to be 35 over 56. And remember, this is a technique of creating equivalent fractions for any given fraction that we've talked about before. Now, notice the denominators are the same for both of the equivalent fractions, and therefore I can now add these two together. And when I do so, 24 and 35 is 59, and then that is over 56. And that can't be reduced, so that's our final answer in this case for adding these two fractions together. Now I want to go ahead and illustrate a second technique at this point, so let me go to the second slide and do so. In this case, I have 7/15 plus 3/20. Now I could do the same thing I just did a minute ago. I could take the first fraction, multiply the numerator and denominator by 20, and take the second fraction and multiply its numerator and denominator by 15, and that would be fine, except that the numbers are going to start getting pretty big. So perhaps we can do something else. Let's take the first fraction, and before we do anything, let's find the prime factors for the denominator, and that would be 3 times 5. And I'm going to do the same thing with the second fraction, which is 3 over 2 times 2 times 5. Those are the prime factors for 20. Now, notice that what we can do in this case, rather than multiplying the first fraction's numerator and denominator by 20, I really only need to multiply it by 2 and 2. In other words, I'm getting the two 2's that were missing from the denominator of the second fraction so that they're included here. And I have to do the same thing in the numerator too. So when I do this, 7 times 2 times 2 is 28. And 3 times 5 times 2 times 2 happens to be 60. And in the second fraction, I notice I have two 2's and a 5. I'm missing a 3. That is, from the first fraction, I know that there was a 3 that was included in its prime factors, so I need to include that 3 here so that when I do so, 3 times 3 is 9. And again, 2 times 2 times 5 times 3 is 60. Notice what has just happened. By only including the prime factors that were missing from one or the other fractions as my multipliers, I now have the same denominator. And in fact, this denominator has a special name. It's called the least common denominator. And the reason why is because it is the smallest denominator that both 15 and 20 evenly divide into. Least common denominator. All right, and in this case, and that's also known, by the way, as the LCD, and in our case it's equal to 2 times 2 times 3 times 5, which is 60. Now let's go ahead and add these two fractions together since they have the same denominator. 28 plus 9, 8 plus 9 is 17, carry the 1, 2 plus 1 is 3. I have 37 over 60 as my final answer for adding these two together. I can't reduce that fraction any further. So at this point, we've now finished adding the two fractions together. And this technique can be used at any time when we find the least common denominator, the smallest number that the two denominators evenly divide into. That technique works anytime.